didn't see you there. Alright, so today we are going to have a video about the probability density function. But firstly, I will show you guys. This is the video from assignment Statistic Engineering ECC3004 for Dr. Amrala, is it? Yeah. Hi Dr. Amrala. So today we are going to give a brief explanation on what is the probability density function really means. Alright. So what does the PDF? Okay. The short form we call it is a PDF. Alright. What is the meaning of it? Okay. The probability distribution, or simply distribution, of a random variable of x is a description of the set of the probabilities associated with the possible values of x. Alright. Okay, after that, the probability that x is between a and b is determined as the integral of function x from a to b. Alright, so I will give to my friend.
Welcome everybody. Today I'm going to explain to you how to convert a histogram into probability density function. So first step is you need to have the data. Let me give you some simple situation on the class that have different marks based on their test 1, which have 50 students, and the average mark of the student is 50 marks. And we create a density. First we create the density histogram of resulting marks. Perhaps the histogram might look something like this. Okay, then on this histogram, the center value is the average mark, which is the well known as the mean. And then we could represent the PDF or the X not as the density histogram, but rather as the curve. Then we need to change this histogram into the curve by taking the center of the rectangle and connecting the dots between the center of the rectangle at the top of the tiny rectangle, and then we obtain the curve. The graph of the curve might be look like this. Okay, then such as the curve is denoted as the fx and is called a continuous PDF. From the curve, the total area under the curve is equal to 1. Next, I will pass this video to my friends.
So now I will explain about the properties of the PDF. Do you know the property of PDF? So, of course you don't know. So let me tell you. There are two basic properties of the PDF. For the first one is the function must be greater or equal to 0. The fx, we can obtain it from the line of the curve. For the second one is the area under the graph must be equal to 1. If you get a negative value, you have wrong answer, and the formula that you use is not correct. So now I will show you the calculation of the PDF. So now I will show you how to calculate the PDF. So for example, if you have a function of x equal to x squared over 3, then we have the area under the curve from -1 to 2. This area under the curve is equal to 1. Then we need to calculate the area under the curve from 0 to 1. I will show you how to find this area. Firstly, we list the formula first, which is the interval of x is from 1 to 0. X is the random variable of the PDF, equal to integrate of 1 0 x squared over 3 dx. Then we integrate this function, we will get x cubed over 9 over the boundary of the integral, which is 1 to 0. Then we insert this both boundary to the formula. We will get 1 cubed over 9 minus 0 cubed over 9. So we will get the answer of 1 over 9. So this area is equal to 1 over 9 cm squared. So that's all. So that's how we calculate the PDF. So now I will pass it to my friend about the application.
Oh, hello. Do you know that PDF have its application? You don't know, right? Okay, now I will tell you one simple application for this PDF. A company that's called McDonald's have the one product that's called Quarter Pounder Burger. It's claimed that on its advertisement, this Quarter Pounder Burger have 0.25 pound. But of course, every burger for this Quarter Pounder have different on its weight. So to calculate the probability from, such as we want the range from 0.2 pound to 0.3 pound, we take a random sample, such as 10 random sample. So from this 10 random sample, we measure its weight, then we mix the procedure like my friend explained. So how to obtain this PDF. So from this 10 random sample, we make histogram like this. So from that histogram, we produce the line curve like this. From this curve, we get its equation for the line. So from the equation from the line, we can calculate its probability. We can calculate its probability by doing the integration process, such my friend explained from its example. So from we do further calculation, we can get probability from range 0.2 pound to 0.3 pound. Okay, that's from my part. That's all from us.
Thank you.